Now let's find the range of this function. There are two ways we can solve this problem. The first way is using the discriminant method. So we can let y be equal to this function. That's just rewriting f of x using another variable. And now, since we want to find the possible values for y, we're going to create a quadratic where y is in all of the coefficients. So now let's multiply the denominator on both sides. Now let's combine like terms with x as the variable. Here we have a quadratic about the variable x. And using the discriminant, we know that the middle coefficient squared minus 4 times the first and last coefficients must be greater or equal to 0 in order for this quadratic to have a solution, to have a real solution. Now we can simplify further. Let's divide -1 on both sides. Now we can factor. From this inequality, we can see that y must take a value from in between 8/3 and +4 inclusive. And we forgot to mention something earlier. We can only do all of these calculations under the assumption that 3 minus y is not equal to 0, or else this whole equation would not be a quadratic anymore. But there is a case where 3 minus y might equal 0. In this case, y would be equal to 3. So in one scenario, we have y equal to 3, and in another scenario, we have y equal to 8/3 to 4, where y cannot equal 3. But when we combine these two ranges for y, we just have a continuous interval from 8/3 to +4. And so this is our range for y.